Okay, this is where we just barely left off. So if you are comparing time with distance, that's kind of sloppy. Time with distance, what you need to know is the steepness of the line is speed. So for example, let's say this mark right here represents 100 miles. So if I have line A hits 100 miles clear at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is 13 seconds. That's pretty dang fast speed if he can go 100 miles in 13 seconds. But anyway, let's say we got line C right here, and line C reaches 100 miles, but he only does it in 3 seconds. So he reaches 100 miles way faster than line A does. His line is steeper. He is going much faster. So steepness, if you're comparing time and distance, steepness is referring to speed. So 7, which car has the cruise control on? It's got to be line A, because he is traveling at a constant rate. His speed is just staying the same. Is increasing at a constant rate. The further that time goes on, the closer he gets to grandma's house. So he's just cruising down the road at 60 miles an hour. But if you have line C, his speed is not changing, his distance is changing, but he is cruising down the road at double that. He's going pretty fast. Okay, which car's speed is accelerating? That is car B. And I know that because of the curve. His steepness is changing. Steepness is speed. So line A, the steepness never changes, so his speed never changes. Line B, the steepness changes, so his speed must be changing. Starts off kind of slower, but then he speeds up and he's getting faster. So the interval where A is faster than B. So look at line A. Where is this line steeper than B's line? And it's definitely steeper from here, maybe all the way to like right here. In that interval, A is steeper. So from 0 all the way to 1, 2, 3, 4, 5, 6, 7, 0 to 8 seconds including. Okay, now when is B going faster? Okay, right here I think this line starts to become steeper, and it's definitely steeper, definitely. So I would say from 8 seconds on, and let's say they end at 13 seconds. So from 8 to 13, B's line is steeper than A. What in the graph indicates the speed, the steepness of the line? Okay, now 12, a third car C is now shown. If all 3 cars have the same destination, and let's say that destination is right here at 12, so which one is going to hit it first? So that line right there, destination is 12 units from the origin. Which car do you predict will arrive first? Okay, I think I got that backwards. So the destination, this is the time. So I gotta remember, this guy is time, and this is distance. So if the destination, the distance is 12, so up here I want to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right there. Not the time 12, I want the distance to be 12. So the distance is this line. Which of those 3 lines reaches 12 first? And it is going to be C. C looks like it reaches 12 at so this is 12 seconds and this is 13 seconds. it looks like it reaches 12 right at 12 and a half seconds. B, it's probably going to be next. B reaches it about 13 seconds, it looks like. And A, who knows when A reaches it. A reaches 12 high, probably not until 20 seconds or something. So C is going to barely beat line B by like half second. Okay, domain and range. So 13. The X axis is the domain and the Y axis is the range. So on the X number line, let's say, this is kind of small and you can't see, but let's say for argument's sake, let's say B is circled but left empty, and let's say A is circled and filled in. Okay, so on the X number line, the horizontal, I want to know from where to where does this line start and end. So this line starts at -1 and it goes all the way over until a +1. Okay, now -1 is circled and shaded, so that means it includes -1, but 1 is circled and left empty, and it is not included. So everything between those numbers is included. Every whole number, every fraction, every decimal, every irrational, everything is included from -1 to 1, because that's a solid line. So every number has a corresponding output. So if we say, what about 0.25? 0.25 is like right here, and if you go up, it does have a corresponding output. Every number has a corresponding output. So that's the domain. If we use interval notation, it's going to be bracket -1 comma 1 parentheses. So the brackets include, the parentheses don't. Okay, the range, the up and down. So now I'm looking at the up and down. How far up, how far down? And it goes down. Furthest it goes down is to like a -1, but the highest it goes up is at 3. -1 is circled and included. 3 is not. So anywhere between there, anywhere from a -1 to 3. So same thing, -1 all the way to 3. Okay, let's do, I'm not going to do all of them, let's do one more. Let's look at 15. Okay, 15. Your x-axis, your domain is going to be, so how far from here to here? But these arrows mean I can assume that line continues on forever. So there's actually no end to the left. They're going to carry on all the way to -infinity. So the smallest is going to be -infinity, but the largest it's ever going to be is right at 2, and it looks like 2 is included. So that's what it would look like. Anything to the left of 2 on the number line, including 2. So let's see, what are we going to have? We're going to have interval notation is going to be -infinity all the way, except for not with the bracket, it's going to have a parenthesis. You cannot include -infinity, but you are going to include 2. Okay, the range up and down. The range, can I cap it off somewhere to a up and down? It looks like these lines are going to continue, so I think the range is going to be, it's going to go all the way to -infinity, +infinity. Okay, I think that might cover them. The only tricky one is like on 20. If you look at this on a number line, 20, you have got -1. You have got 0. You've got a point on 1. You got a point on 2. And you got a point on 3. But that's going to look just like that. You cannot include anything between those numbers. You just have 5 unique points. 1, 2, 3, 4, 5. So if you try and express that with interval notation, you're going to have -1, 0, 1, 2, 3. 5 unique points. That is it. Nothing else. But compared to 19, you have a billion, million, zillion, trillion points. You go, well, the lines go forever. But let's say they stopped. Let's say they stopped right there. You would have anywhere from a -1 including, and you'd stop. Let's say it's the exact same, so we're going to stop right here actually. So we'd go over to 3, and we would include 3, and we would include everything in between. So -1 to 3, brackets on each. Alright, write a model that's going to figure out how many blocks you're going to need for any design. So figure 4. The dimensions. Figure 4 is going to be a 4x4 on the bottom, and it looks like it's going to be a 4x3 on top. Figure 3 is a 3x3 on the bottom, and it's a 3x3 on the top. Figure 2 is a 2x2 on the bottom and a 2x3 on top. So if I can imagine figure 100, what would it look like? If I can visualize 100, then I can visualize figure X. Figure 100 on the bottom is going to be 100 by 100. Then I'm going to have these 2 blocks here. And then it's going to be 3 tall by 100, or 3 wide by 100 tall. Okay, now so for picture X, it's going to be X by X. I'm going to have 2 right here, and then it will be X tall and 3 wide. So the width is never going to change. It's always going to be 3, 3, 3, 3. The height, I notice, is the same as the figure number. So figure number 100 is 100 tall. X tall for figure X, and then the bottom is just the square 4x4, same as the figure. So I'm going to count all these squares. I'm going to do base times height, then I'm going to get x squared. I'm going to count these 2 in the middle, x squared plus 2. I'm going to count these squares right here, x times 3, 3x. So there is my model, x squared plus 2 plus 3x. Now which part of the picture is growing at a linear rate and which one's growing at a quadratic? The linear rate is the upper portion, because the width never ever changes. It's always going to be 3. From picture to picture, it's only changing in one dimension. It's only getting taller. The quadratic rate is going to be the bottom, the square, because from picture to picture it gets wider as it gets taller.